Let's go back to our examples with tree diagrams. And in this case, this is similar to our first example where we tossed the coin 2 times, except now we're adding in a third coin toss. So if you remember from exercise 1, I think it was, when we tossed twice, we had a tree diagram that looked like this. Now adding in the third coin toss, I have more branches coming off. So each of these different avenues has another possible outcome. So if we write out our different outcomes, remember with the tree diagram, we always have to list our possible outcomes. If I follow the branches along the first line, I get heads, heads, heads as my first outcome. Then following along heads, heads, tails is my second outcome. And I could carry on in that way to list all the other outcomes. Now the first question here is, which is better for displaying the possible outcomes, a two-way table or a tree diagram? Well, I'm hoping that you see it's obvious. The two-way table even has the word two in it. So it's only useful for showing two events. In this case, we have 3 events because we are flipping 3 coins. So it's impossible to show 3 events or more than that in a two-way table. As soon as you have 3 or more events, you have to use a tree diagram. Here it says, what is the probability of getting 2 tails? And I'm going to assume that this means exactly 2 and not 3. Okay, so let's highlight all the ones where we have 2 tails. We have 2 tails here, 2 tails here, and 2 tails here. And again, I'm going to leave out this last one because it has 3 tails and I want exactly 2. So the probability of 2 tails, we're going to say is 3 out of a whole possible, how many are in the sample space? 1, 2, 3, 4, 5, 6, 7, 8. So my probability is 3 out of 8. Here's another example where they want us to draw a tree diagram to represent all the possible combinations. A man has 2 pairs of pants and 3 shirts. He has black or blue pants, and then he has a dark, light, or a plaid shirt. So let's look at this and try to visualize it. He has 2 pairs of pants, one's black, one's blue, and 3 shirts, dark, light, and plaid. So if we're looking at how many different ways can he dress, a tree diagram is actually really going to help us. So if he wears the black pants, he can wear any of the 3 shirts with the black pants. So that's one branch of our tree diagram. If he wears the blue pants, he still has the 3 shirt options. So that's the other branch of our tree diagram. So this is all the different possible combinations. We have the black pants with the 3 shirts here, and we have the blue pants with the 3 shirts here. So we can see that we have 6 possible outfit combinations. Now let's look at the same tree diagram, except this time we're going to draw it using words instead of pictures. So we have the same options. You could have black pants with the 3 shirt options, or you could have the blue pants with the 3 shirt options. And now, just like before, all of our tree diagrams, we must list out the final outcomes. We know from before there are 6 possible outfits, and we follow our tree. So you could have black pants with a dark shirt, black pants with a light shirt, black plaid, and on and on. So this is our tree diagram for this type of situation. Our last example, Lian is in charge of selecting boots and socks for his soccer team's kit. His coach tells him he may choose from the following options. For boots, he could have Nike, Puma, or Adidas, and for socks, he could have blue or white. So draw a tree diagram to represent the possible combinations. So let's draw it. Our first option, we have boots, and we have the three options there. Our second event is the socks. So you have each of those blue or white options coming off from each of the boots. So our outcomes, you could have Nike or blue, Nike or white, Puma or blue, Puma white, and so forth. So I can see if I count my total sample space, or the total number of outcomes, I have 1, 2, 3, 4, 5, 6 total outcomes, and I can answer the questions. What's the probability that he will choose Adidas boots? So highlight all the ones that have Adidas, and that is 2 out of the total 6 possibilities, which simplifies to 1 out of 3. Next question. What is the probability that he will choose Puma and blue socks? So Puma and blue socks is only this one option. So my probability has to be 1 out of 6. And then in the last one, let's try and clear a few of these things. Okay. In the last one, it says, what's the probability that he will choose Puma boots or blue socks? So I want to highlight everything that's Puma or everything that has blue socks. So that's this one. We've already highlighted that one that was Puma and blue, and this one. So I've highlighted 4 options out of my total 6, which simplifies to 2 out of 3. For homework, you're going to do page 316, exercise 2. There are 4 problems there. It looks like a lot, but it's really not so bad. And then as an optional extension, so this is for those of you who are going for an A or a B this year. I want you to do page 318, exercise 3, A and B. And there's a video here that will help you. It gives an example of these types of problems. Good luck.